Now, I will briefly explain the abstract of our study. This research focuses on improving product quality and production efficiency using quality control tools in the food manufacturing industry. The case study was conducted at Azahar Manufacturing Sdn Berhad, an SME producing traditional chips. Data were collected through observations and interviews. We applied 7 QC tools and 7 new QC tools, including Pareto, Ishikawa 3 diagram, and matrix diagram to analyze the problems. Based on the Pareto analysis, defective products were identified as the main issue. The causes were classified into workers, materials, machines, methods, and workplace. Improvement solutions were then evaluated using a matrix diagram with weighted criteria. The results show that worker training and job rotation, improved raw material inspection, and preventive machine maintenance are the most critical solutions.
Introduction. 7 QC tools help companies identify type of papers and track down the root cause of problem. 7 new QC tools help companies compare ideas and transfer quality implement strategy. The scope of the study that researchers focus on the problem preparation of the raw material to the packing strategy. Second is to ensure that food safety standards are complied with. Next is to provide production quality. Study objective: identify the main problems in the production process. Determine the root cause by analyzing the factor of product failures. Researchers provide recommended solutions and address the root cause of the problem and improve product quality. Evaluate the progressive of the solution. Researchers use 7 new QC tools to ensure that the improvement measures that are critical.
For background, Azahar Food is a small and medium enterprise that specializes in producing traditional chips. The business was started in 1995 by Mr. Azahar and Mrs. Mariam as a home-based operation and was officially registered in the year 2000. The main processing plant is located in Johor and the company has expanded through branch and kiosks in Bandar Baru Uda, Gombak and Kahun Baru. Azahar Food produces snacks such as cassava chips, banana chips and breadfruit chips. Added cost is on cassava to ensure consistent quality. Today, the company provides job opportunities for the local community and has grown from a small home business into a successful local food manufacturer.
Research regarding the steps taken by the researchers are to understand the 7 QC tools and 7 new QC tools. The next step is to know the production process, identify the main problem, identify the cause of the problem, identify the main cause of the problem, propose to solutions to the problem, and evaluate the solution in the company. Data collection and data analysis. The researchers conduct a study on the production process to find out the problem that and conduct different observations during the interview. The researchers conduct data and analysis the data using the 7 QC tools and 7 new QC tools achieves the objective of the study. Interview. The researchers conduct interview with production manager to identify and analysis problem in the company. The follow chart is production process at Azahar Manufacturing to help researchers understand envisaged problem and analysis problem. The process begins with the preparation of raw material, followed by panning manually and machine. Next, the material will go across the wash press and dry the water. The material is then cleansed and the oil is blended. Do quality control. If the production does not meet the standard, it will be filled again. If it's passed, it will go to the final strength. The product is entered, packing, reverse or session first. The word production will go trust and additional QC before packing. Finally, the product is stored in the stock control warehouse before being handed over the marketing department of sales.
Assalamualaikum, my name is Ifrakila binti Salizam. Moving to 5.1, Pareto chart is used to identify the most critical issues at Azahar Food Manufacturing. We utilize the Pareto chart, a fundamental quality control tool based on 80 per 20 rule. This principle suggests that roughly 80% of problems are often the result of just 20% of causes. By plotting frequencies from highest to lowest, we can clearly see where our productivity improvements must begin. Looking at our data, the most significant challenge is defective products, which occur 23 times, accounting for nearly half or 47.92% of our total issues. This is largely due to the nature of our raw materials. For example, ingredients like tapioca, banana, and breadfruits have a very short shelf life and must be processed immediately upon arrival to maintain quality. Failure to do so leads directly to the high defect rates we see here. Our second biggest hurdle is a lack of employees. With a frequency of 13 and an accumulated percentage of 75.50%, this stems from factors like a lack of experience, unpunctuality, and a reliance on contract workers. Combined with unexpected incidents, which happen at times and are often linked to mission failures in the process department, these three categories represent over 90% of the company's operational struggle. On the lower end of the scale, we see lack of inventory control at three frequencies, which typically involves supplier-side issues. Interestingly, the lowest frequency is environment hygiene, with only one recorded incident. This demonstrates that the company's emphasis on hygiene across the processing, packaging, and the sales department is highly effective. In conclusion, by applying the Pareto chart principles, it is clear that focusing our immediate efforts on raw material processing and staffing stability will yield the greatest improvement in our overall production quality. Thank you.
Assalamualaikum, my name is Ain Hazika. Based on affinity diagram, the company had identified costs into 5 categories, which are material, machine, methods, workers, and workplace. For worker category, there are several issues that contribute to the product productivity problem, such as the worker lack of proper on-job training, lack of experience in operating the machine, high turnover that lead to the employer's shortage and the faults. Other than that, the poor attitude and behavior such as lack of safety awareness and proper punctuality also the cause toward the problem in the productivity. For machine categorical, inflation of product productivity often due to the improper machine layout, insufficient machine, lack of maintenance, and low machine cleanliness. Lack of machine maintenance is lead to the frequent machine breakdown, and hence that affect the product productivity, while the third group effect towards the company product productivity is the material. For instance, high cost, inconsistencies, quality of the material season, weather, excess inventory, and the fluctuating market price for the materials. It is then followed by the subsequent group of method. Lack of the stated standard operation procedure (SOP) had caused the employer to make according to their own preferred and make things out of the superior's provision. In addition, frequent change process semi-automated process has the significant impact on the product productivity also. Lastly, poor lighting and infinitely messy small workplace also contribute to the impact of the production. Based on Ishikawa diagram, results are shown in figure 6. Researchers found out that the main effect from the various costs. Researchers realized that effect of low productivity is mainly caused by 5 major classifications of costs, which are workers, machine, workplace, method, and material. From the view of workers, researchers noticed that lack of employers, lack of experience, and personality and behavior of employees cause low productivity. Next, lack of maintenance. Insufficient machine and improved per machine layout are the source of low productivity. Workplace at the condition of narrow and small, messy and unclean, as well as has the poor ventilation and lighting will be result in low productivity. There are some methods in the production of influence to low productivity. The methods are chemical process, worker change process, and no standard operating production being implemented in the process. Last but not least, the main cause is the material used in the production. Some of the problems in material affect low productivity are the high cost of raw materials, inconsistent quality of materials, and excess inventory. Based on information, researchers must continue to find out the most critical costs that result from the different types of major costs. It is important to propose the correct action.
For this section, I will explain the main causes of the problem using the interrelationship diagram. Based on the diagram, material-related are the strongest cause of production problems at Azhar Manufacturing. Poor quality raw materials such as cassava, bananas, and breadfruit directly affect product quality and productivity. Since these materials have a short shelf life, delays in processing can easily lead to spoilage and defective products. In addition, supply disruptions such as weather and crop diseases cause inconsistency in raw material quality. The second major is workers. Production depends on skilled workers, especially for cutting and inspection. Lack of training and experience increases human errors, which then affect machine operation and quality efficiency. Machine-related issues such as breakdown and inconsistent packaging also contribute to production delays and defects. Other factors like methods and workplace layout have a smaller impact and mainly cause minor operational delays rather than major defects. In conclusion, the interrelationship diagram shows that materials are the root cause, followed by workers and machines, while workplace factors have the least influence.
Next is tree diagram. This tree diagram explains the improvement action to reduce defective products, focusing on materials, workers, machine, methods, and workplace. First, for materials, the company should improve supplier selection, carry out stricter raw materials inspection, and apply FIFO inventory management. Having backup suppliers can also help prevent shortage. Next, for workers, proper training, clear standard operating procedure, and job rotation are important to reduce human errors and dependence on a few skilled workers. For machine, regular preventive maintenance and recalibration are needed to ensure accurate packaging. Investing in more reliable machine can also reduce breakdown. In terms of methods, standardizing processes and improving production scheduling can help reduce delays and bottlenecks. Lastly, improving the workplace layout and organizing storage area can improve material flow and reduce congestion. Overall, the action work together to improve product quality and reduce defects.
Hi everyone, my name is Divyashini Anaperempuan Sa Krishna Rao. For my part, I focused on evaluating the proposed solutions using the matrix diagram. The diagram helps prioritize solutions based on 4 criteria: low cost, shorter time, priority, and competency of operators with weights of 7, 6, 10, and 4 respectively. We used 3 scoring symbols: a shaded circle for high impact, white circle for medium impact, and a triangle for low impact, with scores of 9, 5, and 2 respectively. After scoring and calculating the totals, the highest priority solutions are raw material inspection and approved supplier framework, each with a total score of 219. These solutions directly tackle the main cause of defective products from materials. Next in priority are worker training, job rotation, preventive maintenance, and standard operating procedures, which also improve production quality, efficiency, and consistency. Overall, the matrix diagram provides a clear objective way to select solutions, helping the company reduce defects, optimize operations, and enhance overall product quality. Thank you.
In this discussion section, the study demonstrates how the application of the 7 principles and 7 new tools effectively identify and analyze quality problems at Azhar manufacturers in Diem Berhad. The process flowchart revealed that the production process involved many manual and semi-automated steps, creating multiple points where variation and defects may occur. The Pareto analysis showed that defect products are the most critical issue, contributing for 7.92% of total problems. Using the affinity Ishikawa diagrams, the root causes were categorized into materials, worker, machine, methods, and workplace. Material-related problems such as inconsistent quality and short shelf life were found to be most influential. The interrelationship diagrams further confirmed that inconsistent material quality, easily spoiled raw materials, and lack of skilled workers are the 3 most dominant causes. Based on this finding, the 3 diagram proposed targeted improvement strategy across all 5 categories, including stricter raw material inspection, worker training, preventive machine maintenance, standardized procedure, and improved workplace layout. Finally, the matrix diagram ranked the solution based on cost, time, priority, and operator capability. The highest priority solution identified were raw material inspection and approved supplier control, followed by worker training and job rotation, and preventive machine maintenance. In conclusion, the main issue identified in this study is defect product, which significantly affect productivity. The key root causes are inconsistent and easily spoiled materials, lack of skilled workers, and machine reliability issue. Based on the analysis, the top priority solutions are strict raw material inspection with approved supplier, worker training and job rotation, and preventive machine maintenance. Overall, the application of quality control tools has proven effective in identifying problems, analyzing root causes, and prioritizing improvement action. This measure will support productivity improvement and strengthen the competitiveness of SME in food manufacturing industry.